block, sir? Wouldn't the glass shatter, sir? You know what?
No, no, we don't heat it that much. All right.
Oh,
All right. You see, if you place the metal block in water, right, and you wait until you wait until you place the thermometer right beside it, and you wait till it reaches 100, right? The entire
yes,
system will
sir.
be 100. All right, the entire system will be 100. So you could use the 100 as your initial temperature of the mass of the block before you place it in the calorimeter.
Oh, all right, sir.
All right. So remember, Q is equal Q or EH equal to what again? Let me start you off. Mass times, what's the next one?
A.
Mm,
No,
no,
mass times volume.
no. All right.
Oh, what, sir?
You're saying something, Tyrese?
Yeah, I was asking for what? Didn't hear that. What you said.
For the heat capacity equation, we want to find the heat energy. So we said it would be mass times C, right? Times change
Of
in
the heat.
temperature. You remember this from last
Yeah,
week?
for real, for real. Yes, sir. Yes, sir.
All right.
Yes, sir.
Delta
So
T.
we put this down here. All right, let me get it out. This here. All right, so let's say the mass of the water, right, is E times C, C of the water, right? This is the heat capacity, specific heat capacity.
Which is still lab 9, right?
Yeah, that's what we want to accomplish for our next lab. All right, so we're going to carry out this experiment times the change in temperature
Do we need to say that?
equal mass of the block or mass of the, what we call it again? Mass of the,
Mr.
yeah,
Treasure.
metal. Question,
We did 8 labs the last time, right? So how much we're
right?
gonna cover this time?
We'll talk about that soon. Soon enough. I'm still in the process of marking them. Right, you're going to get them back to make your changes and then put them in your official lab book. And then we talk about but more than likely will be online, right? That's what we're arranging now. Arranging for the labs to be online this time. All right, so CM and delta T. All right. Now we know. Let me see in the chat. All right, so I wish more persons were here. All right, guys, I really don't want to go over this again. This is a lot we want to cover today. So the next step would be to look at the temperature, right? We know the temperature is, right? So the final temperature of both of them will be the same, all right? The final temperature of both of them will be the same. Sorry about that. All right, so let's put water here, and let's put, um, well, the heat loss would be the metal. The metal is the one that loses heat. Sorry about that. Some of those changes. Yeah, the metal is the one that's losing heat to the water, right? So we have metal, metal. I'm just switching them. It's the same thing. And then we have water. The water gains heat. All right. So the change in temperature of your water, and then you have mass and change in temperature of your. All right. So how would you calculate now the specific heat capacity of the metal? We want to find this. What would you do next? What's the next step?
Um, using that formula, right, sir?
Yeah, using this formula here. How do you do this? Want to get rid of the M and the delta T, right?
We go carry over, I say.
Yeah, so we won't carry over
Wait,
the M and yeah, we're going to transpose. We're going to carry over the M and carry over the delta T, right? How would you do that?
Divide.
All right, so we divide
Cancel.
both sides by M
Yeah.
and divide both sides by delta T. M and delta T, M. So these will cancel, right? These will cancel, leaving us only with Cm equal to Mw, right? Over M and M. Are we all seeing that, right? If you're not seeing that,
Over
please.
MN, sir.
Yes, sir.
Yeah, MM. Is that M also, right? Are we all clear?
Can it over, sir.
All right, so we have a relationship. This is the relationship for finding the heat energy, right? So we have mass times specific heat capacity times our delta T. Delta T is a change in temperature. So as we are aware that the mass changed temperature, the mass got cooler, so therefore it lost heat. And our what's that?
I'm taking notes, sir.
All right. Remember that you don't have to take notes. Remember that I post them on Google Classroom.
Sir, with the variety, sir.
Okay, it's better for us, no problem. All right, so and then we have the heat gained here. So the water was the one that gained heat, and the mass, the mass or the metal, it lost heat to the water, right? So the next step would be to find the specific heat capacity of the metal. That's what we want to find. That is our aim. So we transpose this equation here, and we basically divide both sides by m, which will be the mass of the metal, the mass and the temperature change. These two will cancel, leaving us with this relationship here. All right.
So where's the Q represented in?
Q is heat.
Right.
Heat energy. And it's the same thing as EH, right? EH is heat energy as well.
Sir.
All right. Any questions?
No, sir.
All right. So you finished writing theories?
No, sir. Soon.
Who is that now? I believe it's Turner.
Yes, sir. I'm finished.
Turner, where exactly are you confused at? Alright, you can't just lost, right? You have to be lost at a particular point, right? You understand that the metal loses heat and the water gains heat? You understand that?
Yes, sir.
All right. And you understand this relationship from last week? Were you here last week?
No.
Right. The notes are posted on Google Classroom and also the videos. So did you get to watch them over?
Fred didn't hear me.
Right. I'm asking if you got to watch over the class. when you get the time, please watch them over. Right now, this is a relationship for the heat capacity. Now, this is a specific heat capacity. This is your heat energy. This is your mass and your delta T. Right? If you
Answer.
watch over the class, you will get a much better understanding. You have a question, Darius?
Yeah, you're going to cancel out one side.
Right, it is canceling out the M and the delta T.
Oh, okay.
Yeah. All right, Mr. Turner. So this is a relationship, right? And remember, for a system, we're assuming that the heat energy never changes. So the heat energy before is equal to the heat energy after the or the energy before is equal to energy after. So when we add the metal block to our water, right, we're assuming that there's no heat loss, right? No heat loss here. The heat is not given off here, right? Because we're using an insulated cup. All right, so that's the first relationship. This is your formula for finding heat energy. So we'll just apply the same thing. Probably my handwriting is not so good, so I'll erase pen and show you. I believe this is a much better explanation. So we have MM here, and we have CM delta TM, right? And we have the same thing over here. Of course, this negative means that the heat is going towards the water. All right, this heat is going towards the water, but the negative is not in the final equation. You won't have a negative sign. All right, you won't have a negative sign in the final equation, which is just signifying that the heat is going towards the water from the metal block. All right, so for this side, we want to bring over the M and the delta T. So we would divide both sides by M, and we divide both sides by delta Tm, right? And these two would cancel. These two would cancel, and it would leave us with this final equation here. So we have everything here. You have all of these, right? We have the change in temperature of the water, or the change in temperature of the mass. We have the specific heat capacity of water. We have the mass of the water, and we have the mass of the metal, right? So we have all of these, and we apply our formula, and we get the specific heat capacity of metal. Are we clear now, Ms. Turner?
Yes, sir.
All right. Remember to watch over the videos if you weren't at class. Is everyone else clear? If you're not clear, please stop me. Please interrupt me. All right. Okay. We only have 10 persons here today, which are 9 students out of 20, I believe. Right, or 19. So I don't know how it's going to go because I believe you'll be tested on this as well for your final exam. So I hope it works out. So suppose we have 104 grams of the metal, and it's heated to 100 degrees Celsius. So we're assuming that when we heat this and the water begins to bubble, right, as soon as it begins to bubble, the mass will absorb the same amount of heat, or the mass will be at the same temperature. That's what we're assuming, right? And it's fair, right? And it is placed into 54.21 grams of water at 17.5 degrees Celsius. The final temperature of the water and the metal is 22.0 degrees Celsius. Right, so what would be the specific heat capacity of the metal, right? And then after we find out, we can determine that. But let me just add one more slide here and come back for the calculation. Give me a second. Question?
Sir, I got the temperature.
Go again?
Temperature. Are you going to teach us temperature?
If I'm going to teach you temperature?
Yeah, like what? Sorry. Like, never mind.
All right. Type a question again. I'm gonna see if I understand it better there, because probably I'm not hearing it. All right, type your question in the chat. All right.
Hold on. Anybody in the class finish their manuscript and they say, can't hear me with it, please, man.
All right, let's try this
By
again.
looks size, some people get different manuscript.
All right, so let's continue.
Same manuscript.
About 4 months when I said, we don't know channel for the bread of it, honest.
All right, so it's physics time now, right? Let's try and finish this. Okay.
Nice.
Yeah. So the mass, we said the mass of the metal is 104. So mass of the metal is 104.58 grams, and the mass of the water is 54. Mass of the water 54.21. All right, so I believe this is Mrs. So will you teach us how to calculate the temperature or the temperature overall? All right, so yes, I understand much better now. So that temperature, right, is we got that from the thermometer, right? We read that straight off the thermometer. That particular temperature here, we got this straight off the thermometer. All right, so we read the temperature, the temperature of the water before and after straight off the thermometer. We didn't calculate it. All right. I hope that answers the question. Please tell me if it doesn't. And the temperature of the metal. So the temperature of the metal. Temperature of the metal before. That would be initial temperature. This is 100 degrees Celsius. 100 degrees Celsius, and the temperature for water was 17.5 degrees Celsius. This looks like an 8, right? And the final temperature of both of them, so I'll just put that as TF, right? Because the temperature of both of them is the same. We put that at 22.0 degrees Celsius. All right. Now, let's go to a calculation. We will copy this particular equation here. Where is our equation? All right, so it would be Cm equal, so we'll copy this and just place it over next slide. So we have Cm, put it over here. Cm equal minus mass of the water. All right, set this.
Class, what is C?
Go again.
What is C?
C is the specific heat capacity, all right? CW, specific heat capacity of water. Cm, specific heat capacity of the metal.
All right.
All right, so temperature change in water. Remember, if you're not following, please stop me, right? And delta Tm. Now, let's put in our values, right? Let's start with the mass of the water first. What's the mass of our water?
54.21 G.
Grams. Grams, did I say?
All right, so it's in grams. So what we do?
Grams, the G.
Right, so we convert this.
Because of water, brother, water measure in liter.
Kilograms, sir.
Yeah, so what would we get?
0.054.
All right, so 0.054, right, times the specific capacity of water is 4,200. All right, you can go back to the last slide, or it will be in this slide as well. All right, but it's 4,200 joules per kilogram. And
enemy.
our change in water, right? It would be the final temperature first, right? So that would be 22.0 minus 17.5. 17.5. And we'll do this for the next one, right? Mass of the metal. What is the mass of the metal?
104.58 gram.
All right. So what is that in kilograms?
0.104.
All right. So 0.104, right?
Yes, sir.
Times the change in temperature. So what was the final temperature of the metal?
100 degrees Celsius.
No, that was the initial temperature. All right, what's the final temperature? Remember, we place both of them in the same calorimeter and we wait for it to for the temperature to go to equilibrium, right? So the mass and the water, the metal and the water would have the same temperature, right?
All right, yeah. That's
Yeah.
22 degrees Celsius.
So the final temperature, what would be the final temperature?
22 degrees Celsius.
Exactly, 22 degrees Celsius would be the final. 22 minus 100, minus 100, right? Now let's find out what is happening up here. Let's say 22 minus 17.5. What we get on our calculator? Twenty-two minus 17.5.
22 minus 17.5.
Yeah.
Not that they count.
All right.
Must
So
get
same as this.
4.5.
4.5.
All right. So yes. So Moss says 4.5 as well. So that means it's correct, right? We're all saying the same thing. 4.5. No. Let's find 0.054 times 14 times 4,200. Zero point zero five four times 4,200. Right?
Must get the answer, sir.
All right, let me check. All right, so I see 226.8. Yes, I get the same thing as well. Times 4.5, and then let's find 22 minus 100. All right, so negative 70. Are you sure? All right, try that again. Okay, 78. So negative 78, right? And this will be times 0.104. Now let's find out what's happening at the top. All right, we have less than a minute. So I'll close here and you join back, all right? I'll end this call and you join back as quickly as possible. We want to finish this today. All right.